Hello everyone, this is the end of term 3 revision, grade 8 math. We're gonna start with chapter 1 revision. In this question, they ask us to determine if the two figures are congruent or not. Let's start with the first shape. For the first shape, as you can see, we have different size. So they are not congruent. Not congruent. To say that the two shapes are congruent, they should have the same size, same shape, same angles, same side length, everything should be the same. Both figures should be identical to each other. If we went to figure or question number 2, we have two triangles and they look the same size, same shape. We have to determine the sequence of transformation. So we can tell that they are reflected. First, let's start with a triangle ABC and try to reflect it across the x-axis. Remember, when we reflect a point, the distance from the point to the reflection line, it's the same as the distance between the reflection line and its image. So here we have 1 unit between the point and the reflection axis. Also the image, C prime, it will be 1 unit away from the reflection line. So here we're gonna have C prime. B, it's 1, 2, 3 units away from the reflection line. So also its image will be 3 units down. This is B prime. And point A, it's 1, 2, 3, 4 units up the reflection line. Its image will be 4 units down the reflection line. Here we're gonna have A prime. Okay, now I'm going to connect between the points. After the reflection, we have a translation. We translated the figure 1, 2, 3, 4 units to the left. Also, you can check for point B, 1, 2, 3, 4. For point A, 1, 2, 3, 4 units to the left. So we can say that first, yes, they are congruent. And the sequence of transformation, first we have a reflection across the x-axis, and then we have a translation 4 units to the left. Okay, now let's go for question number 3. Here the question says that these parallelograms are congruent to each other. So they are identical to each other. We have to determine the sequence of a transformation. So we can tell that parallelogram CAMP is rotated 90 degrees and then translated down a number of units. So first we're gonna try to rotate it 90 degrees counterclockwise. These are the rules. For 90 degrees counterclockwise, as you can see here, we're gonna change the position Y with X, and then we're gonna put a minus sign for the Y value. Okay, so first, for example, if we have 5 and 3, we're gonna change their position. So it will be 3 and 5, and then we're gonna put a minus sign, do the opposite sign for the Y value. So it will be -3, 5. Let's go back to our question. Let's start with point A, rotating it 90 degrees counterclockwise. The coordinates for point A, we have 1x and 2y, 1 with 2. So first, I'm gonna write them here. We're gonna change the position, x with y. So we're gonna have 2, 1. And then we're gonna put a minus sign for the y value. So it will be -2, 1. This is the image for A after rotating 90 degrees counterclockwise. negative 2, this is negative 2, and 1y, it will be here. Now for point C, the coordinates for point C, 1x and 4y, do the same, flip the position, 1 with 4, it will be 4, 1, and we're going to put a negative sign, so it will be negative 4, 1. Negative 4, 1, it's here. This is A prime, and here we have C prime. Okay, for point P, the coordinates for point B, 1, 2, 3, 4, 4x, and 2y. We're going to do the same. It will be the image for P will be 2 and 4, and we're going to do the opposite sign, so it will be negative 2 and 4. Negative 2 and 4. So it will be, this is negative 2, and here we have 4. So now it's obvious, the shape here, and here we're going to have M prime after rotating it. Okay, so after rotating 90 degree clockwise, counterclockwise, we're going to translate it down. Let's see, for point C, we have 1, 2, 3, 4 units down. Let's try point A prime, 1, 2, 3, 4. That's it. So first, we have a rotation, counter clockwise, and rotation 90 degree counterclockwise. And then we have a translation, four units down, 1, 2, 3, 4 units down. Okay. Now for the fourth equation. In this equation, also we have to determine if they are congruent and what transformation could be used to create logo if figure A is the pre-image and figure B is the image. This one is the original and this one is the image. So here you can say that we have a reflection across a horizontal line, reflection, and then translation to the left. Or you can say a rotation, then a translation. Both are correct answers. I will say we have a reflection across a horizontal line and then translation. Also the same for question number 5. Here we have a reflection across a vertical line, and then we have a translation a number of units down. So are they congruent? Yes, they are congruent, but we have a reflection across the Y or a vertical line, and then we have a translation. Okay, multiple choice. We have a trapezoid QRST and its image are shown. What transformation maps trapezoid QRST into trapezoid LMNO? So we have a reflection across a horizontal line. Reflection across a horizontal line. Okay, let's continue. For this part, they want us to write the congruency statement, comparing the corresponding parts in each set of congruent figures. Remember to pause the video, try to solve these questions by yourself, and then check your answers with us. Let's start with the question number 1. The order here is very important. Let's start with angle W, it's congruent to angle. As you can see here, we have one arrow, and if we check the other figure, the angle with one arrow is X. So angle W is congruent to angle X. Then angle U is congruent to angle Y, two arrows. Angle U is congruent to angle Y. And the last thing is angle S is congruent to angle T. This is for the angles. Now let's go for the sides. Let's start with side W, U, segment W, U. It's congruent, as you can see. We start from angle W to angle U, and the corresponding side will be from X to Y. So it's congruent to segment X, Y. Next, let's take this side length. It's connecting U with S, and as you can see, we have two dashes. So it's congruent to this one. And as I said, the order is important. You have, if we start from U to S, segment U to S, you have to say it's congruent to YT. Next, let's take WS, segment WS, it's congruent to segment XT. And the last thing, we can say that triangle WUS is congruent to triangle. Now we have to follow the order. We start with W. We have to write first the corresponding angle for W. The corresponding angle for W is X. We have to start with X. Then we wrote U. The corresponding angle for U is Y. We have to write here Y. And the last thing is S. And the corresponding for S is T. That's it. Let's go for the second one. Let's start with angles, and then we're gonna write the sides. First, angle M is congruent to angle Y. Then we have angle N is congruent to angle Z. Then we have angle O is congruent to angle W. And the last one is angle P is congruent to angle X. This is for the angles. And for the sides, first segment MN, it's congruent to segment YZ. Then NO, segment NO, it's congruent to segment ZW. Then segment OP, it's congruent to segment WX. And the last one is segment PM. It's congruent to segment XY. So we can say that trapezoid MNOP is congruent to trapezoid YZWX. And as I said, the order is important. Since we start with M, we have to write the corresponding angle for M, which is Y. Here, as you can see, M, it has one curve, and Y also, it has one curve. They are equal and congruent. So we have to follow the order. Like here, we put N in the second angle, and here also we have to write the corresponding for N, which is Z. For question number 3 and 4, we have to do the same. I will write the final answer. Like here we have triangle KMR is congruent to triangle QLP. And from this statement we can find all the other corresponding sides. Like angle K is congruent to angle Q, or angle R is congruent to angle P. Or you can say segment KM is congruent to segment QL, first two with first two. Or we can take the last two, MR with LP, also they are congruent. Or you can say RK with PQ, also they are corresponding and congruent to each other. Okay. I will write here for question number 3, the final answer. Triangle FGE is congruent to triangle HGJ. Now for question number 5, it says that we have a design shown with a triangle RST is congruent to triangle RWX if the measurement for WXR equal to 62. When we say measurement for angle WXR, we mean this angle. W, from W, go to X and then go to R. You're gonna make an angle. This angle measure 62. The measurement for angle X equals to 62. What is the measure for STR? This is the angle that they are asking about. S, T, then R. This is the angle, okay? If the measurement for angle WXR is 62, what is the measurement for angle T? As you can see here, T is corresponding with X. Since they are congruent to each other, they have the same measurement. The measurement for angle T is equal to the measurement for angle X. So the measurement for angle T is 62. Okay, for question number 6, they told us that triangle BEA is congruent to triangle ARB. The length of BE is 90 feet. BE, the first two, BE, segment BE is correspond to segment AR. So, and they are congruent to each other. They have the same measurement. If BE is 90, also AR will be 90. So, we have a 90 feet. Okay, now let's go for question number 7. Remember to pause the video. Try to solve the questions by yourself and check your answers with us. Okay. In this question, it says we have a roof construction shown triangle ABC is congruent to triangle DEF. If AB is 8.5 and AC is 10 feet, what is the length of EF? So here in the question, it told us that AC is 10 and AB is 8.5, and they ask us to find the length for EF. First, these two triangles are congruent. They have the same measurement, same side length, same angles. They are identical. And EF, as you can see here, EF is correspond to BC. So EF is correspond to BC. It have the same measurement. If we were able to find CB, it's the same as EF. So we're gonna find CB and it will be equal to EF. To find CB, as you can see, we have a right triangle. We're gonna use the Pythagorean theory. The sum of the two smaller squares is equal to the larger square, the hypotenuse square. So we're gonna say, let's assume that the side length CB equals to y equal to the square root of 10 squared minus 8.5 squared equals to 10 squared is 100 10.5 squared, let's multiply. 85 times 85, we're gonna remove the decimal point, multiply, and then we're gonna put the decimal point back again. 5 times 5 is 25, 5 down and 2 up. 5 times 8 is 40, plus 2 is 42. 8 times 5 is 40. 8 times 8 is 64, plus 4 is 68. Let's add 5 to 12, 7. Put the decimal point back again, 72.25. Okay, let's subtract 100 minus 72, 27, the square root of 27.75. Okay, we're gonna estimate this number. The question asks us to round to the nearest tenth. 27.75, it's not a perfect square, so this is irrational number. We're gonna round it up. We know that the perfect square nearest to 27.75 is 25. The nearest is 25, which is 5 times 5 gives us 25. So we're gonna round it up, like we're gonna try 5.3, for example. Let's try 5.3 times 5.3. I'm going to remove the decimal point first, multiply and put it back again. Our answer should be close to 27.75. 3 times 3 is 9. 3 times 5 is 15, plus 5 times 3 is 15. 5 times 5, 25, plus 1 is 26. 9, 10, 8, 2. 28.09, which is very close, so it's acceptable. 5.3. Y, which is segment CP, equals to 5.3 approximately, and this one is equal to EF, to segment EF. Okay, now let's go for question number 8. Also here we have two congruent triangles. It says that the measurement for DE is 20 yard and the segment DF is 40. They ask us to find the distance from K to L. K to L is correspond to EF. So we're gonna find the measurement for EF, and it will be equal to KL. Also, we're gonna use a Pythagorean theory since we have a right triangle. Let's do it. Let's assume this is y. The measurement for y is the sum of the smaller two squares. This is the hypotenuse. The longest side length is equal to the sum for the smaller two squares. مجموعهم الاثنين الصغار. 20 squared plus 40 squared. This gives us 400, and this gives us 1600. If we add them together, we're gonna have 2000, the square root of 2000. 2000, it's not a perfect square, so what I'm going to do, I'm going to say that 2000, it's 220 times 100. Okay, and the 100, the square root of 100 is 10, so this is equal to 10 times the square root of 20. Then we're going to approximate the value for 20, the root of 20. The square root of 20, 20. The square root of 20 is between the square root of 16 and 25, but it's closer to 16. Here the difference is 4, but here the difference is 5. So it's a little bit closer to 16 and almost in between. So we can say that this is approximately 4.5. This is equal to 4 and this is equal to 5, and the square root of 20 is somewhere in between, so we can round it to 4.5. Now we can multiply 10 times 4.5, give us approximately 45. Okay, now let's go for question number 4. It says Jenna is creating a mural for her bedroom wall. She would like to copy a picture that is 2 inches by 2.5 inches. So the original picture is 2.5 by 2. she uses a copy machine to enlarge it by a scale factor of 4. So she multiplied by 4. The new dimensions will be 2.5 times 4 give us 10. 2 times 4 is 8. After that, it says then she projects it on her wall by a scale factor of 12. So again, she made it more bigger by a scale factor of 12. I'm gonna multiply this by 12, and the width also will be multiplied by 12. 10 times 12 is 120. 18 times 12, 10 times 8 is 80. 2 times 8 is 16, 96. So the new dimensions are 120 by 96 inches. For question number 5, which sequence of transformation can be used to show that two figures are similar but not necessarily congruent? Similar, to make figures similar, we should have a dilation, because reflection, rotation, translation keeps the dimensions the same. It doesn't change the dimensions, it doesn't change the size, it keeps the image and the pre-image congruent. Only dilation can change the size. Okay, if dilation not equals to 1, then the change or the size will change. Okay, so the answer, dilation and rotation. Okay, now let's go for question number 6. A graphic designer enlarged a rectangular image with a length of 3 inches and a width of 5 inches. Let's graph. Okay, we have this picture with 5 inches and 3 inches. He wants to enlarge it by a scale factor of 2. He wants to make it bigger by a scale factor of 2. So the new dimensions will be 5 times 2 and 3 times 2. So the new dimensions are 10 by 6. Then he decided that the enlarged image is too large, and he wants to reduce it by a scale factor of a quarter, 0.25. So he want to make it smaller by quarter. We're going to multiply this by 1/4 or 0.25. Also here we're going to do the same. We're going to multiply by 1/4. 10 divided by 4 is 2.5. And 6 divided by 4 is 1.5. So the new dimensions are 2.5 and 1.5. Then the final image will fit into a rectangular space that has an area of 3.5 square inches. So we have to find the area of the final image. It's 2.5 by 1.5. To find the area of a rectangle, we have to multiply length times width. Let's multiply 25 times 15. We remove the decimal point. 5 times 5 is 25. 5 down, 2 up. 5 times 2 is 10, plus 2 is 12. 1 times 5 is 5. 1 times 2 is 2. 5, 7, 3. And we had 2 digits for decimal part. Here, this is the first digit. And here we have the second digit. So the final answer is 3.75 square inches. 3.75 is bigger than 3.5, bigger than the available space. So the answer, no, it will not fit. The answer, no, it will not fit on the wall. Now let's go for question number 7. It's similar to question number 6. It says an artist needs to reduce the size of a painting. The original dimensions of the painting are 12 by 20 inches. This is the original dimensions. We have 20 by 12 inches. She reduced the painting by a scale factor of 1/4. So the scale factor is 1/4. We're going to multiply the length and the width by 1/4. The length is 20 times 1/4, and the width is 12. We're gonna multiply it by 1/4. 20 divided by 4 is 5, and 12 divided by 4 is 3. So the new dimensions will be 5 and 3. She then decides that the reduced image is too small and enlarged by a scale factor of 2. So she wanna make it bigger again by a scale factor of 2. We're gonna multiply the new dimensions with the scale factor, which is 2. 5 times 2 is 10, and 3 times 2 is 6. So the new dimensions are 10 and 6. Will the final image fit into a rectangular space that has an area of 55 square inches? The new dimensions, or the final dimensions, are 10 by 6. If we want to find the area, multiplying length times width, it will be 60. This is the new or the final image space. It will not fit, since here the amount of space is smaller than the final image. So 60 is bigger than 55, so the answer, it will not fit.